Okay, Cloud Gurus, let's see what this cluster autoscaler actually looks like. And like I said, there might be some subtle difference between cloud providers. I'm going with the Google Kubernetes engine for this demo because they've always had the most integrations, and you know what? I know it works. But the overall process, no matter what cloud platform you're on, is going to be pretty much the same. So, job one's obviously to create a cluster. Name's not important, right? But what the heck, I'll go with something meaningful. I want to stick it somewhere close to me. And I'll have an up-to-date version, thanks. Now, node pools here is where the magic kind of happens. On GKE, you hit Advanced Edit here. Of course, this will be different on other clouds, but the concept's the same. A group of like nodes that Kubernetes can expand and contract as needed. Now, I don't care about the name or anything, just these auto-scaling bits. In fact, you know what, before I do that, let me just have the pool start out with one node. Right, now the minimum and maximum are what you'd expect. Don't ever let the pool go less than 1 and never more than 10. And there's a bunch more you can set, but that's the auto-scaling stuff. And of course you can add more node pools if you want, maybe with bigger instances or something, but I think that'll do, so we'll just create that cluster. Now that's going to take a minute or whatever, so I'll come back when it's done. Okay, now then, we can see cluster size is 1, and these here are the CPU and RAM properties of that node. So if the cluster autoscaler adds more nodes to the pool, they'll get the same. So pretty small, yeah, 1 CPU. Anyway, I'm gonna need this here to connect. Now, I appreciate it's a gcloud command, so specific to Google, but all it's doing is configuring kubectl. Okay, and we should be able to see our single node cluster. Alright. Now then, to make the rest of this demo clearer, I'm going to jump forward in time 5 minutes so that this age field goes up. It'll make it easier to spot the new nodes later on. Anyway, let me jump forward in time, and don't worry, right, if your lights flicker or anything, that's just me stressing the fabric of space-time. Okay, should be 5 or 6 minutes now. What? Eh? 10 hours? What? Oh, I guess I've got my calculations a bit wrong. Never mind though, let's crack on. So we've got the cluster with a single node and auto-scaling configured to scale the default node pool anywhere between 1 and 10 nodes. So now we need an app. This is a deployment, a single replica, and then down here in the pod spec, a single container running Nginx. But the important bit's the resource requests here. Asking for half a CPU, yeah? So, every replica that we spin up for this deployment is going to ask Kubernetes for half a CPU. If the cluster's so busy it can't fit in the new pod, it's going to spin up more nodes in that default node pool. Now then, let me reiterate. This putting pods into pending and the subsequent spinning up of new nodes and the likes is all based on what pods are requesting, not what they're actually using. So the cluster can be practically idle, but if you're running pods that have asked for resources, that's what gets taken into consideration. Well, I've got a copy of that YAML in my directory here, so let's spin that up. Okay, have a look at it. Right, well, we're asking for 1, but none are available. Now, that could be waiting for an image to be pulled, but I reckon it's a lack of resources. Okay, pending, but why? Right, failed scheduling, insufficient CPU. And if we're lucky, we might even see a new node being started. Feel like some wildlife photographer, if we're lucky. Oh, magic, we do. And not quite ready yet, but you get it right. Not enough CPU, so we spin up a new node. And if we check again... Right, now it's up and running. So what about our deployment? Okay, not up yet. And this is good, right? Because we're seeing that as cool as this is, right now, we haven't got a way to get around the time it takes to spin up a new node and add it to the cluster. So we'll stick a watch on it though. Ah, bingo. All up and running now and all automagic. But you know what? Just for the fun of it, yeah? Let's make that 10 replicas. Redeploy that. Check it out again. Oh, hello. Oh, you know what? I know what that is actually. I'm not editing the version in my working directory. So yeah, let me come here and save that to the lab directory. Should work if we post it again. Hopefully asking for 10 this time. Alright, much better. But obviously, right, only one available, yeah? Because I'm hoping in the background it should be spinning up some nodes. Stick a watch on that. Now, watch the node names, okay? These are not new ones yet. It's just the way that the watch refreshes. There we go. Whoa, flipping heck, loads of them. And you know what? If we jump over to the Google Cloud Console here, drill into our cluster here and look at nodes. A bunch of new nodes spinning up, all initiated by the cluster autoscaler in Kubernetes. Brilliant stuff. Well, let's do a recap to help us remember some of the stuff that we've learned.